Up, up. Okay. Thank you for coming. Okay, so my goal today is to talk about a bit our experience at Pix4D with AWS and insist a bit on the fact that AWS allowed us to scale and to do a software company without any infrastructure investment at scales that in a bank it would be hard to reach and where you would have tens of people to do the same thing. I'm saying in a bank just as an example. I used to work in a bank. So that's me. I have been at Pix4D for more than 3 years now. I'm a cloud architect, and kind of what I do is everything from the API level, so the web API, down to the infrastructure. We don't have anybody else in the around, so it's a mixed bag of skill set to do database, VM, application server, programming, whatever. That's it for me. So today I want to give you an overview of what we do on AWS. I'm just gonna up. So my goal is to give you pointers on many things, to try and go deeper on some of those things, so that I get some benefit from this session. It's to share some experience. I have some slides ready that I'm not as happy as I am with some of the other presentation I have done. So if you can make it interactive and interrupt me and ask questions, that's going to be better, I think. And I have a sore throat, I have a bit of a cough, so actually if you interrupt me, that's also going to be good for me if I stop speaking. So please interrupt me. Okay, so quickly about the company, Pix4D. We are now an international company. We were issued from the EPFL, from the Computer Vision Lab. We are 200 plus people now, most of them 150 plus in Lausanne. And what we do is photogrammetry. And photogrammetry is the science of taking measurements from images. So that's what I was saying a bit before we started. From images that are overlapping images, we try to generate 3D models and 2D ortho images of what we see. And the way it works is exactly the way your human vision works. The fact that you see the world in 3D is because you have two eyes, 2 points of view, and your brain recomputes based on the difference of what you see. For the computer, it's the same. We take several pictures of the same scene with a different point of view, and then we can, with the effect of 3D, we can recompute what was the original object, to make it very simple. Okay, so that's our motto, information from images for better and faster decisions. So what is it useful for example? For example, you take some pictures of a query. That's a query in the Vaud canton, north of Lausanne. So that's a big query, and you can see here on the 3D model, there is a small gravel pile here. So that's a stock pile for the query. And because we have computed a 3D model, we can take measurements and compute volumes, for example. So we have mines and query that do their stock management with a drone. Once a week, they fly above their stockpiles, and they just compute the volume. And that's their stock management. Another use case is for emergency response. We have a new product that is going out on that. And we take picture of an accident, and we can reconstruct what it was. So this is an actual training facility in the US for emergency first responders, so for firemen and people like that. And this is an actual collision, car crash that happened, I don't know where, I can't recall. That was taken with Pix4D. And what's important why it's important is that you have a conflict in such an event between people that want to remove the vehicles from the road so that traffic can resume, and people that want to document the entire collision for insurance purposes, more or less. Okay, and so that means measuring the size of a tire track that you have on the ground to see if there was a braking track or things like that. And what we do now with photogrammetry is that they can take a snapshot and get everything out of the road and do these measurements later. So that's one of the newest use case. That's not something that we figured out. That's something that our client figured out. We did photogrammetry for surveyors that were using analog photogrammetry, which was an awful process. And now that it's easy and cheap, some other people are doing things, and now first responders are very happy with that. Okay, so Pix4D was a doing a desktop application, started 8 years ago. And 3 years ago, we started to do cloud. Okay, and what is the cloud for Pix4D and what do we do in the cloud? So in a Pix4D general workflow, you have to capture some data. So that's done with drones or your camera. And then you have to process the data. So either on your local computer or on the cloud, because if you use our software to process your data, basically you put your computer on the side and you don't touch it while it's running for a few hours, because you cannot do anything else while it's running. Okay, it's a very computer intensive process. So you can do it on the cloud so that you can still use your machine. And then on the cloud, we also have analysis tool, because what you want to do after you have your 3D mesh and your 2D model is to be able to do some annotation, to share it with colleagues, to do measurements that can be done on the cloud or sometimes on desktop, depending on the use case. Okay, so to give you a bit of an idea of scale, we run about 1,500 virtual CPUs to do this processing, okay, with the number of projects we do per day in the cloud, knowing that today the cloud is a very small business part for us. Most of our clients, they do that on their own hardware. So actually the number of CPU that are used by Pix4D worldwide is certainly a lot bigger, but that's already a reasonably big number to have 1,500 CPUs for a small company. We have 1.2 petabytes of user data right now. Okay, that's 1.2 million gigabytes. Okay, so that's a bit of data, right? We use 20 Amazon accounts, so we don't keep a single Amazon account. I'll talk a bit about that. All of that is, we are cloud native, so we were able, it was easier for us to try and do everything new and good. And so we are never down. Okay, so we do one release a day at least, and we are never down, more or less. I think we have less than 5 hour downtimes in the last 3 years that we operated an actual product. We deploy daily. We do database deployment, database changes about once a week, which means that it's possible and you don't have to do that quarterly like in most companies. And what's very important is that we have no ops resources. Okay, we have no people whose job it is to do infrastructure. It's basically the backend developers. And more than that, I think that if I try to sum up how many people, how many resources we spend on running our product and building our product on this size of infrastructure, I think we are using less than 2 people, 2 people equivalent. Okay, I'm doing 80% of this infrastructure, I think, and some people are contributing, and I'm spending less than half of my time on infrastructure work.
To see for how many developers?
On the cloud side, it's a bit hard to say because we are exploding, but let's say on 6 backend developers. But I think it's less. Huh? I'm putting 2 because otherwise you are going to say I'm lying, but I think we spend less time. Yeah. So, how is it possible? Because that's the big question, and that's my main point throughout this presentation. And the main point is automation. This is a book about DevOps. If you have not read that, if you want to read a book about DevOps, that's the one to read. It's written as a novel. It's written as a story. Yeah.
There's a second one coming.
Yes, it's not out, and it's not about DevOps exactly. But yes, there is another book from the same from Jin Kim that's coming out. Yeah. Okay, so it is about culture and practices and why it's important to do DevOps. But automation is key, right? If I had to log onto every of my machines that compose this 1,500 virtual CPU to install a Linux distribution and put it and update it and whatever, that would never work, or at least not with just less than 2 FTEs. And that is possible because of Amazon or because of the public cloud as a concept, right? They are not the only one, but today we're talking about them. Okay, and sorry, what do they bring? One thing that I have seen in the past is that when you have an infrastructure team, and even worse, when your infrastructure team is actually a different company outside of your company or kind of inside your company, which happens a lot in the banking sector at least, everything you want to do is contractual. Okay, so in the old world, when you wanted a new machine to do a deployment, you had to ask your infrastructure, they had to buy something, and so that's normal that you have this complicated process. In the new world, and if you deploy on the public cloud, getting a VM is clicking a button. So how come it takes a provisioning process, manual process of weeks to get there, right? And weeks is money, it's headaches and everything. In AWS, in a public cloud, that's a click of a button. Okay, you can code everything. So as a developer, I code completely my infrastructure. Okay, and I will show a bit how I do that. But basically, I don't click buttons. Okay, everything is coded, and all the advantage of that is that it's reproducible. It's I have an audit of what I have done because I have all the version of my infrastructure in code somewhere. So there are all the good things about infrastructure as code. It's controlled through API. So again, I don't have to click. Actually, I'm actually calling a programming language to control that, which is much better than clicking, because when you click and when you do a procedure to say, okay, in test, I did that to get my new infrastructure and to set it up properly. Please do that in production. When we do the production release, something is going to go wrong. Okay, so that's one of the things about infra as code. And also, now that the basis of the infrastructure, the public cloud, is ready, and it has been for a few years with Amazon, they start to provide higher level services. Okay, the database starts to become a service. Before you had the VM on which you could install the database. Now the database itself is a service, for example, and higher level, which means that you have a lot less things to do. Okay, so what do I mean when I talk about infrastructure as code, which is the most important thing around automation on this subject of public cloud infrastructure Amazon? I'm not talking about those things that you might know. Okay, most people infrastructure code, they talk about that. That's kind of the old school, because those things are meant to do one more provisioning. And provisioning is you already have your infrastructure and you want to install something on it. Okay, you want to install your Linux distribution, you want to put a Java executable, you want to maybe deploy your application there. And we are actually before that, okay, where now we want to control this infrastructure. And there are basically two tools in the Amazon world. There is the Amazon tool, CloudFormation, okay, that has, I'm not going to talk about it today because I'm going to talk about Terraform. That is not Amazon specific, and because of that, it has a bit of advantages and well, whatever. I'm not going to try and compare them. I use Terraform, so that's what I'm going to talk about. And those things are going to enable me to describe my infrastructure, not what I install on it, but what is my infrastructure. And those tools also, Ansible, Puppet Chef, they are also made irrelevant. Thank you. Who was that? Thank you. They're also made irrelevant because often now you deploy it through Docker, and your Docker contains the runtime environment. It might have been provisioned with Ansible, but often it's simply a Docker file. I'm not going to talk about that anyway. So Terraform. What is Terraform? It's an application, or it's a language that enables you to describe your infrastructure. Okay? And so that looks like that. So for example, I want an S3 bucket, right? Everybody's familiar with S3? Amazon S3? Okay, a bucket is just a place where you store data in S3, which is a file system. We'll simplify it like that. And for example, I want to provision a resource of type bucket that I will call like that, and it has a name here. It is in a certain region of Amazon, and then there are some options that I can or put or not. Those two lines are the only ones that are necessary in this particular case. Okay, all the rest is overriding defaults that I wanted different, but they are default for everything. So you don't need that. The same way that in the Amazon console, in the UI, you could click on create a bucket, and that's basically the only click you have to do if you want to put a name, and that's it. And what does it enables me to do on top of just describing my infrastructure in code? It gives me two additional features that are super interesting. It gives me dependency resolution and diff application. So dependency resolution is something like that. I have my S3 bucket that I just showed you, and now I also have a policy on the bucket, okay, that is containing the rules to access the bucket. And this is, as far as Terraform is concerned, this is a different resource. But this is a resource that needs to apply itself on the bucket. So here, you have this AWS3 bucket S3 data ID is actually referring to the other resource, okay? And what it's going to do it's gonna infer that this resource on the left needs to be created before the resource on the right. And I have tens of resources in my infrastructure, so this is extremely practical because then I don't need to care at all about what do I do first. It all solves so it solves it for me as long as I use proper referencing. If I hardcode the name there, of course, I cannot know that it's the same as here. But if I just say that's the same resource, it can do the dependency graph. So that's the first power of Terraform. And the second power is different diff application. So I have this description of what my infrastructure should be. I will change it because I want to do. I want to add a new bucket. I don't know what I'm doing here. I want to create a lambda, I guess, whatever. And there is a difference between what I already have and what I want to have with my new description. And Terraform will tell me when I ask to apply this new infrastructure, it will tell me, okay, I need to create this resource. This is brand new. This did not exist before. And I need to modify this one, so there is actually a plus minus, so there is actually a replacement because I was changing the retention day, for example. So as far as Amazon is concerned, that is a setup that I can change. So that would have just updated the resource, but because I'm changing the name also, Amazon cannot do that. It's an immutable property. So it tells me, Terraform tells me, well, it will force the replacement. So I will drop this resource and create a new one. That doesn't tell you, by the way, whether your application and your infrastructure will continue to run fine when you apply that. Okay, that's still a human job to know whether you can do that, apply, and still have zero downtime when you do that. Okay, you might have to find a migration path that is iterative. That's not going to help you. It doesn't know what's represented behind. Sorry. Clear? Okay. So a bit of a return of experience of what we do with Terraform. For prod, there is no question. All our prod is in Terraform, or at least not the legacy part maybe, but everything is in Terraform. Everything should be scripted. That's the only way to ensure that you know what you have in prod, that it's reproducible. And actually, humans should not have access to prod in write mode. So I don't have access in prod in write mode anymore. It's not actually true because if I can deploy my Terraform recipes, that means that I have some access, but it's not the access I usually use. It's a bit protected. So when I go to prod, I am read-only, and that's it. In staging and dev, you want generally to use the same script because that's the entire point. That's that what you have developed, you can prove that it's the same thing that is going to go in production, and you know that when you are going to do your production deployment, it's going to work because it's the same thing. So you want it to be as similar as possible, therefore you use the same script. When you do R&D, however, you might want to discover a new service, right? Right now, I am developing a new service with SNS, which is a notification service of Amazon. That's the first time I use it, so there are a few concepts that I need to grab that I need to understand. And so I started by clicking in the interface. That's normal, but and it's practical. But even there, I quickly go to Terraform because when you start to click in the console in the Amazon UI, you don't know what you are doing. It is creating all sorts of things for you. Actually, sometimes one click of a button will create all sorts of things. When you create a VPC, a network zone in the UI, it creates an internet gateway for you. If you do it through the API, you don't have that because you might not want an internet gateway in this particular VPC. You might not want internet access. Okay? And so it's harder to clean up because you don't know what's created, and it might not be exactly the same process to remove what you have created. Sometimes it says, oh, I need a role, I will create it for you. And also, I was saying it's practical to do it with manually, but actually once you get into using the tool, that's quite simple to use. And I get benefits, I get speed improvement by directly going to Terraform. It's not a burden for me anymore. And also, if I do most of my R&D with Terraform, that's going to help me to create and drop seamlessly. I can also easily move to an actual dev script because my R&D in the end produces the dev script. Okay?
Are you saying you're only using Terraform to interact with Amazon infrastructure? Like all you want, you don't use like APIs, scripting, or because you were first talking about scripting, and then Terraform.
So Terraform is using the Amazon APIs. Okay, so it's a front end kind of, or it's an application that will orchestrate all those API for you. So I do have a few things that I do manually with directly the APIs with the Amazon CLI, that I might talk a bit about later. But yeah, that's Terraform is controlling 99% of everything I do. Because everything I will do through API but manually, I will forget that I've done it. Right? Nothing is managing it for me. Whereas in Terraform, there is this notion of state. Terraform knows that you have created an S3 bucket, and if you remove its definition, it will tell you, oh, you have removed it, I want to remove the bucket. Because it ensures, or the goal is to ensure that the image that you have in your definition is actually what you have in production, or under the management of Terraform. You can have other things that it doesn't know about. Right? Okay. Going further, we use Terraform for more things now. We started to do security as code. So actually, because the firewalls and the firewall rules are infrastructure for Amazon, you can manage them through the API, and therefore your security in terms of firewall is in your code, if you put everything. But we can go further, and now what I do is that my user provisioning, my IAM users, so the users that can access Amazon, they are in Terraform, they are in GitHub, and so when a user that is generally a developer, because only developer will interact with Amazon, wants some different access, wants to create some access, he does a pull request for me. I just can review it, approve it, and my CI system will just apply it, and here is his account. Okay? It's a bit more complicated than that, but it works. I want to do the same Terraform as a lot of connectors to other things, so to the other major cloud providers, but also to services that are not cloud providers, like GitHub. I want to put my GitHub accounts also there. It's not that bad. And I was telling you that I was creating accounts for the company, and even creating Amazon accounts is automated. Okay, there is really nothing that I need to do manually anymore, I think. Sometimes I do things manually, but this is because I'm taking shortcuts, or I don't know how to do them better, but I think there is nothing I need to do manually. Okay, so that's my story about automation. That's the reason why we can do what we do with so few people. Okay, which is absolutely not possible without a public cloud and without the automation that is around.
I have a question. I don't know if you tackle it later.
Yeah.
You encounter the issue of basically handling your DNS through APIs.
Yes.
I know that I think Obash has an API, but I don't know if hostpoint.ch they have an API. I was already thinking about it, but
so my DNS is in Terraform in Route 53. Okay. There is a kind of a chicken and egg problem there because of the fact that you need SSL certificates, but to validate your SSL certificate, you need the DNS route to be there. So actually, if I try to apply from zero my current Terraform deployment, it will block at one point. I will need to, it will crash. Amazon will need to do it or I don't. I think I will need to wait for just the certificate to be validated so that it exists, and then it will go through. I need to reply it.
I did tackle this with a Kubernetes cluster where you use Let's Encrypt, like the server manager, and there it's okay. You say, oh, I need this IP, and then I need you to provision this certificate, and it waits until the DNS gets. The question is if you use API to change the DNS record of an IP to point, or URL to point to an IP.
Yes, we do, but we generally never have to. Because in Amazon, the way our deployment works is that we are using an Amazon load balancer, okay, Elastic load balancer or application load balancer in our case, and there is basically no concept of IP. They just give you a name that they can map to your DNS, and they manage the fact that it's a high availability thing and that the IP might change, and so the DNS might change accordingly. That's not your concern. So you don't have to manage those little details because it's all part of the service. And so my DNS, in what I do today, I never change them. Or I add some from time to time, but I never have to change any. In this case, that could be problematic, or I don't know if it could be problematic because you still want the definition to be maybe in the code and deployed with, but I see one. Okay. So I'm going to talk about a few Amazon services that we use to give you a bit of regional experience on them. Storage, compute, a bit of security, a bit of organization, unless you stop me because you are fed up with me. And yeah, let's go. So storage. Storage is organized a bit in terms of, okay, we have 1.2 petabytes of data. That's quite a bit for a company our size, okay? That's nothing for Google, but that's quite a bit for most companies that don't have those scales yet. And of course, there are some challenges, okay, with those, and I'm going to go through storage with those challenges. So there is a security challenge, okay? How do you ensure that this data is secure? And basically, there are two things. So the in-flight is secure because you access it through HTTPS, okay? But then at rest, it's secure. I don't know if you have any experience trying to encrypt hard disks that you have in your own infrastructure with solutions like Volumetrics or things like that. I don't know how many people you need to maintain that, and you need to manage your own cryptographic keys and not lose them, obviously, in a secure fashion. That's very, very complicated. You have pages of procedures in the places that do that properly. In Amazon, I want my S3 bucket to be encrypted. I want my hard drive of my VM to be encrypted. I flip a switch. That's a bit sad. That's not automatic. By default, yes, but I flip a switch. I say yes, and everything is encrypted. Okay. So, there is no challenge actually. Okay, cost. So that's interesting. How expensive is 1.2 petabytes? Okay, if you had to do it yourself, I don't know. I haven't tried. I have tried a bit to look at what's the cost of a gigabyte, but it's difficult. Think that those 1.2 petabytes, those are data that are in S3 and that we want them in S3 because we want those 11 nines durability. The fact that once it's in S3, we are basically sure it will never be lost. Okay? And the way to do that, whether it's Amazon or someone else, is to have 3 copies at least. Okay? So we are not talking about 1.2 petabytes, we are talking about 4.5 petabytes. 4.6. 3.6. Wow. Whew. It's good that I'm recording that because... Okay, so that's a lot of data, and of course at this scale the hard drives they fail. Okay, so you have to change them regularly without having any downtime to your availability of the data. So you have people that manage it. I don't want to know how much it costs. So it costs a lot less, I think, on Amazon, but still for us it's $30,000 per month. Okay, that's a lot of money, and so even if it's not a lot. At this scale, that's still a lot of money for a smaller company. And so we wanted to have a look a bit at what we could do with that because, we cringe a bit. So in S3, we have this concept of storage class. Okay? So those are different types of storage. Typically, Standard is very well known, that's the default, that's S3. And Glacier is known because that's where it's an offline storage. Okay, you put that on tape somewhere, and it's a lot less expensive, but you also know that if you want the data, you're going to wait a few days. Now they have expedite, but whatever. And so, what do we do with that? Okay, so this one is the one we use, that's the one that is expensive, that's the default one. We cannot use Glacier because we want the data to be online. Okay, in our platform, a user can log in and he wants to see his data, so we cannot use Glacier. We cannot use OneZone IA because, as its name suggests, the data is stored in a single zone. So then your data might be lost in a massive event of an entire data server being wiped out, which is rare, but you don't have those 11.9 durability of what, 3, 4, 2? I don't remember, 2 maybe. Yeah, whatever, something, a lot less. So that's not really for us. So there is infrequent access. Infrequent access, it's interesting. You pay less for gigabyte stored, okay, about half as much, but you pay more if you access the data. I think 10 times as much. Well, I don't recall that more, let's say. And so then the question became, okay, what do we put in infrequent access? Okay, you want to put the data that's basically not accessed anymore, that has a very low likelihood of being accessed anymore. So you start to think, and most of our users, they do their project, they do their rendering, they get their model, their maps, and after a month, basically it's done. They don't care anymore. The data stays there as an audit and everything, but they don't care really, so they don't access it. Now that's actually true for some of our population of users, but not some other population that might resell this data to their own client, or some people that put that on the web in a public blog article, and so it gets a lot of hits. And it's hard to choose, and maybe putting everything in IA would be good enough on the scale, maybe not, and it was very complicated to take a decision. And luckily, last year, Amazon introduced intelligent tiering. And intelligent tiering is a new storage class, actually, that basically will move the data from standard to IA. When the data has not been accessed for 30 days, it moves to IA. Basically, as soon as it's accessed, it's moving back here. And for that, you pay a small management fee per file, or per millions of files. We have 1.5 billion files, so that's still money. But basically, Amazon will decide for us. Zero engineering cost to get a lot cheaper storage. Okay, and that's for us. We could do better. We could pay less if we were to figure out the rule to put data there. But it would be a lot of investment that maybe would never actually work. Zero investment. Okay, next challenge. Transfer. Yes, sorry.
Before you
Yeah.
this, there's no limitation or no difference between the I/O performance in
No.
this case, because IA is just used for storage. Glacier, not
No,
storage or
IA is exactly the same. It's just that they propose you a different pricing model.
yeah. So first time you access it, it's still on IA, and the intelligent tiering will move it after install.
So I don't know what. So as far as I understand it, this is just a billing difference, but the data is actually in the same place.
Okay.
So this is just changing the metadata for your bill at the end of the month, as far as I understand it. Because IA, the fact that it's infrequent access does not introduce more latency, less durability. It's all the same guarantees.
Mm-hmm.
So as far as I understand, behind it's exactly the same thing. It's just the billing that is a different model, and you can choose.
The cost consists also of the data transfers?
No. I have a slide about that. Okay, latency bandwidth. Okay, our projects, okay, the people that use our software, most of them use drones, and most of the modern drones that are not very high-level professional drones, they have a 20 megapixel sensor. Okay, that takes images in JPEG that are about 5 megabytes. Okay, and the project is hundreds of images. So every interaction with our product, every new project at least, that means several hundreds of megabytes of data that transfer to us when they give us the images, and back to them when they get the results, the mesh or the automosaics. So that's a problem because the internet is congested. Okay, our servers are in the US because they have to be somewhere, and we have some users in Australia, for example. Okay, and our users told us, 2 years ago, your service is not usable. We cannot use your cloud SaaS offering. We have to stay on the desktop. We want your cloud, but we cannot use it. And basically, a company that is not using a public cloud, its only solution is to put servers all around the world and manage multiple data centers. Okay, with Amazon, you have another solution. So just note the reason why it's super difficult to go from Australia to the US. It's because that's a map of the undersea cables. Okay, the internet is a very complicated network, and there are very complicated algorithms to try and find the fastest route. And you have buffers all the place that create queues and everything. The network is super complicated. What is Amazon's answer to that? Well, they just built their own network because they have the scale to do that. So they have a very, very simple network, a lot simpler than the internet, and it's custom built. And that's what they use for their own data center communication. And because they have that, they say, you can use it for a small fee. So our user in Australia, rather than trying to find a route in the internet to go to the US, he will go to the closest edge location. Amazon has a few hundred edge locations in the world. So he will go to Sydney or whatever, to an edge location that's close. And from there, he will take high-speed custom-built fiber optic to go to the data center in the US. And he will not see the internet. The internet is just from ear to ear. Okay? He bypasses all the traffic. Okay? Yes?
So you have to do something specific for that?
So to do that, you have to flip a switch on your bucket to say you can use transfer acceleration, as it's called. And then your user or your application needs to access your bucket through a different URL. So you have a URL that goes through the internet and one that tries to find the shortest route through the acceleration. And you have to activate it because it's an additional fee, of course, because you use their network. And so there is a bit of a 50% increase on transfer cost or something like that. which transfer costs are very reasonable, so that's not a huge amount of money, but that's the money. And by the way, this Amazon backbone, so it has been available through S3 for a long time, but now you can use it for anything. So if you have your own web servers that serve some API, you could serve your API through this backbone for your Australian users, which maybe, if you are just serving a 100 kilobyte JSON, you don't care about, but you can. Yes?
Have you ever had to deal with locality of the data? Let's say that
Yes.
you would have pictures that have to be
Yes.
in Switzerland.
Yes. So not Switzerland, because Amazon has no data center in Switzerland, so for the moment we don't manage that. But we do end up having a cluster, an S3 bucket and some compute for data locality in Japan, in Korea, and in Frankfurt for the people that don't want to be in the US. So Korea and Japan generally want their data to be on their soil. And European customers generally don't want to go in the US, so we have a Frankfurt one. We would like a Swiss one, but Microsoft is building one, so maybe Amazon will.
No, I said GCP.
There is a Google one?
Yeah,
Ah, okay. Okay, yeah. And we don't have a Chinese one because it's not Amazon in China, it's a contractor that exposes the same thing. It's a bit complicated, so we looked a bit at it and we figured that it was not worth it. And anyway, it seems that the Chinese public is less interesting in a cloud solution. So for the moment, we don't do that. Okay, next, transfer cost. Okay. So you pay transfer costs from and to a bucket, an S3 bucket, okay? With respect to long-term storage, that's a small fee, but that's still money that you have to account for. And also, obviously, the clients are giving us data, okay? So that's a cost for us when they give us the images. But also, they put the images in S3, which is very fine for long-term, but then we have to take those images and put them on our processing servers and do something with it. And maybe we put an intermediary result in S3, and then we have another process that will take back this intermediary result to produce the final result. So there is a lot of data transfer. If you don't do anything, and you have your Amazon VPC here with some compute instances here, and this is an Amazon region actually. We are in the US, not the Amazon world, just a region. And we have an S3 bucket in the same region. Okay, so physically they are actually in the same data center. Okay? And if you try to go in your bucket with the typical URL, you will take this route. You will exit your VPC through the internet gateway. You will go to the internet, or at least to the router of Amazon that is outside, facing the internet, and you will go back in. And you know what? That's this connection between the external router and the bucket that they use to monitor traffic and bill you. So by default, if you transfer your data from the same data center to your local data center, you pay fees. Okay? But there is a solution to that, and it's called the VPC endpoint. You just have to know that it exists. It's again a couple of clicks to create it. So it's a VPC endpoint of type gateway because there are two types, whatever. It costs nothing for S3, and basically it, to make a long story short, it acts as the DNS so that when this guy wants to access this URL, it takes a shorter route, never goes out, you never pay. Super important. Actually, we did not realize that at the start, and so some of the transfer costs were like, yeah, that's a bit stupid. The data is in the same place. Why are we paying? Actually, because there was a bit more setup to do. Okay, why is it not automatically provisioned by default? Yes, some people don't want it. Okay, access challenges. Okay, so our data is in the public cloud. We have images that belong to this blue guy, and we should not serve those images to this green guy. One thing that I should tell you is that, well, no, I'm going to tell you on the next slide. Okay, so we have two ways of doing that. We have our old way, that is kind of more secure, but that has some drawbacks, which is we have a bucket that is not a public bucket. Okay, so you need to be authenticated to Amazon to be able to extract data from there. And so we have our servers, our own servers. They have some authentication. They know how to access, they have an identity as far as Amazon is concerned. So they can access the data. Okay, no problem there when we want to compute something on the user's data. The problem comes when the user that is on the internet wants to access this same data, okay, whether it is or not. And one thing that we decided very early was that the data that the user is interacting with does not go through our servers, through our application or web servers, because that would be, first it would have to go through the US because we only have servers in the US, that's already enough to manage. And then because in terms of bandwidth and everything, we can compare to directly going to S3, plus this transfer acceleration, lots of things. So this user, through his application, desktop application or mobile or browser-based application, he wants to go directly to S3. But he's not authenticated, we don't know who he is, or Amazon does not know who he is. So how does he get data? The way he gets data is that he asks our server here to give him a temporary set of credentials. Okay, simple token services, secure token services, I think, STS. So he gets a token, and we basically craft a token that gives this guy access only to the part of the S3 bucket where we have stored his own data. Okay, so he gets some temporary access to a subpart of our S3 bucket, and so from there he can get the data or write the data depending on who he is and what we give him and whatever. That's very secure. That has a few drawbacks, and one of them is that it kind of forces you that all the data that belong to this guy are in the same folder, because you want to give access to a certain portion, and so it's not possible to list all the files that he has access to. You have to basically give him a folder because you are limited. So that's one of the constraints. There are a few others. So now we have changed a bit. We are using a public bucket, so everything is publicly accessible. But we are so anybody can access it. But we are using a cryptographically secure random string in the path to the file, so that basically if you don't know where the file is, there is no way you find it. Okay. This is a 256 bit of entropy, so that's I don't know, I don't remember, 77 zeros, something like that. So brute forcing it is not possible. Quantum computer won't change that. It won't find the one good solution faster. So we are safe. Okay, and the last one, I think, maybe a bit more complicated. Who's familiar with that? Yes. Sorry.
This forge of this URL is temporary?
No.
So it means if the client gives it to someone, then it's compromised.
Yeah, I have two answers to that. If the client gives you a resource on the internet, you can download it, so he has given it to you for life. Okay? That's the first answer. The second answer is that we have a process to move the files if the user wants to unshare something. But as soon as you share something, it's the digital world. You have shared it. They can download all the bits and they have the data.
How long is the crypto random? How big is
256 bits.
So you could guess it.
No. 77 zeros. 10 and 77 zeros. No.
So why you
256 bits. It's a binary, not 256 characters. It's not ASCII.
Why you switch to this other way? It was too slow.
No, the main reason, there are several, but the main reason is that to give him access to a part of our bucket, we need to know which part of the bucket. Okay, so basically all the data of this user has to be in the same folder, and that's a limitation for us with what we want to, how we want to organize the data. And if you wanted to give him access to a list of 1,000 things that are not in the same folder, you would think, well, I could list those 1,000 things. But actually, there is a limitation on Amazon on what you can give access to or the length of the policy you can put. And so you very quickly hit that length. So we did not want our data, the structure of our data storage to be linked to the ownership anymore, because we have some use cases that don't work anymore. Okay, who is familiar with this thing? That's all? Okay. That's the CAP theorem? No? Okay. So this is the reality of today's world, where you are doing internet scale applications, and you are dealing with distributed applications. Okay, we don't have a single database and a single application server anymore. We have the distribution of everything. And this tells you that the CAP theorem tells you that you cannot have those three things guaranteed. Okay, in a distributed system where there are several servers, you can have two of them, but never three. You cannot be both consistent, available, and partition torrent at the same time. And because it's a network, you can be sure that partition will happen. So basically, no system will say that this is not happening. So because you want that to be strong, you don't have access to this zone. So you are either CP or AP. What that means? Let me try to put a bit of image around that. What I told you is that S3, to enable this 11.9 durability, the fact that they will never lose any data for you, they keep 3 copies. Okay, so when I have given them this black file, they actually have 3 copies of this black file. What happens when I want to update this file, overwrite it with a new version of the file that is now white? Okay, I'm going to connect to a single node because I don't need to connect to all 3 nodes that would have higher latency. One node might be a bit less responding right now because it's under a lot of load, whatever. So I actually connect to a single node and I upload my data to a single node, maybe 2, I don't know exactly what happens, doesn't matter. What matters is, this is at some point there is something like that, and then there is a chatter algorithm on the network that will replicate that to all the nodes. At some point, that's called eventual consistency, everything is consistent. Okay, but there is a time where it's not consistent. And during this time, most often it's microseconds. So most often at the human scale, you never see this problem. At the machine scale, you might, more often. And sometimes at the human scale, you can because some of the S3 server was a bit slow. So it can take seconds. Sometimes they can have some problems. The point is, this is a situation that exists where this file is white here and it's still black there. If at this time you ask for this file, you don't know which one you will get. You have no guarantees. Okay, and that's a constraint you have to play with. And that's a constraint that has a few solutions. And the one we use is that they have actually a better guarantee for new files. Every file that you update, you have this problem that you don't know upon reading which one you will get. Every new file you create, there is some fancy way that you know that if you just created the file, you can get the same file. And there are some conditions, and there are bits. I'm not going to dig into that. Come to me if you want to have more details, but that's something that you have to deal with, but there are ways to deal with it. So basically, we always create new files, or we try to. And if we have a new version, we put it somewhere else, and we just change our pointer in our database to say now the file is in a different place. And we don't let our application overwrite. We have a few rules to manage that. All good? So that was storage. I'm taking a lot of time. If you want to stop, we can stop. But I have something to talk about in compute. Maybe a bit. Yeah, I don't know. I'm a bit less convinced about this part. You will see. So that's a journey. The other one was a few challenges we had to solve. In compute, we went through a journey, let's say. Okay, so the first thing we did is we invented Fire. We did what most people would do in the first implementation of a cloud. We provisioned VM, and we installed Linux on it, and we installed our application on it, and we put a systemd process that was looking at this, and it was basically the same thing that you would do on your local servers. You would install things on your server. That's a bit old school. There are a few reasons we did that. The first reason is that when I arrived, there was a bit of that already there, so it was just easy to continue because it was already there. So we were using Ansible, okay, the thing I said that I'm not talking about it. Well, actually at that time we were using Ansible because deploying an application was, or having a new node in our cluster meant installing, provisioning an actual Linux machine. Not very interesting. Okay, so the next step was to use a container orchestrator. Okay, Kubernetes is the most well-known right now. We chose ECS, which is the kind of equivalent for purely Amazon. I'm not going to talk today why. Come to me, see me later if you want. But what it did is that basically we have to provision some EC2 machines, but that's Amazon doing it through an auto-scaling cluster. So if a machine goes down, it just puts one back up. It knows that we want 3 machines, so there are 3 machines always. I don't have to care about it. I have my Docker containers that are defined somewhere, and then I have a service, ECS service, that is defined that says that this Docker image should run 5 times on this cluster composed of 3 machines. Okay, and it's just going to deploy that. And when I have a new version of the cluster, of the Docker image, I will just say redeploy. It will manage the fact that some of the containers have to be shut down so that I have some space to add some new, but it will manage all that. That's our app servers running with this technology right now. So if you know Kubernetes, that's kind of the same thing. There is still one thing we need to do there. It's this thing here. So what is underlying the orchestrator, what is underlying your Kubernetes or your ECS cluster? It's actual VM. And on those VM, you have an operating system, Linux. You have a Docker instance, Docker client, sorry. In this case, you have an ECS client, but you have a Kubernetes client to know how to connect to the Kubernetes cluster. And I think I'm missing something, but you have at least those three things. And those three things, they evolve. Security patches, new features, whatever. They constantly evolve. So actually, your underlying machines, you want to change them regularly. Okay? And so even if Amazon will give me an image of the newest machine with the latest Linux, the latest Docker, the latest ECS client, I still have to orchestrate a bit this deployment. I have automated it. Okay, so I have a way to do a click, and it will just do a rollover of my entire cluster, EC2 cluster, without shutting down my service. Everything is automated, but I still need to do it. It happens, I don't know, depends, but once a month, something like that. So 1 year, 2 years ago, Fargate came up. And Fargate is Amazon telling you, we can run, we still have an orchestrator, ECS, to run your payload, but you don't have to give us machines. We'll give you machines when you need them. So if you want to run these tasks, we'll just provision the VM that corresponds to the requirement that you're asking. Okay? And we put that in production 3 months ago. And of course, there is a cost for that because, of course, they manage more things for you. So basically, the CPU time is twice as expensive. Okay? But we got 30 to 40% reduction. And the reason is we were over-provisioned before. So that we could manage our burst and everything, we constantly had compute capacity that was underused. Okay? And also because the smallest machine of Amazon, they don't have quite the same guarantee, so we never have the very small machine. We have at least the M class, which starts already high, and whatever. The point is, we were underutilizing our machine. Now, we use our machine 100%. So we actually got cost reduction. And also, we never have to rotate our VMs, underlying VMs anymore, because every time we ask for a task, they provision a new VM for it. And it's going to be new. It's not going to be an old one. So we always run on the latest image possible. So less work for us. Okay? So that's we don't do that, for example, for our app servers, because it costs more for the per CPU time. And for the app servers, we know exactly how much compute we have up at any point in time, because we have 3 servers always, or 5, or whatever. But for the tasks, that is the user using our platform and asking for more compute to do something, we just use that because now 100% utilization, provision on the fly.
Does this use serverless computing? Like where it's just telling what to compute and they provide you
Kind of. So the only thing you have to provide is the Docker image and the configuration of the VM you want underneath. So how much CPU and how much memory. So it's kind of serverless, but it's not quite what they call serverless, or what we call serverless. Serverless is that. It's the next step. It's Lambda, where you just give code. Because there you have to give a Docker image. So you have to give basically the image of a machine that has an OS, that has a runtime environment, that has an application server that manages all your small code. Lambda is really this concept of I just have the code of my business logic. And it certainly runs in an application server somewhere because there needs to be some HTTP connection that goes to it. There is a need to be some high availability, but I don't have to manage that. Okay, Amazon does it for me.
For Fargate, you specify that you want some VMs.
You say kind of what you want, but they manage it for you. Yes.
Know that it's VMs.
Yes.
So
Yes.
it's serverless and serverless.
But you have VMs underlying the Lambda. You don't manage them.
You don't say in this Lambda I want.
You don't have to. Yes. Yes, it's true. You don't even have to give a configuration of the. Yes, that's true. So we are newer to Lambda. Okay, we are using it for some kind of sometimes for event processing and orchestration. Because one of the things that is great with Lambda, if you are working in an Amazon ecosystem, is that it hooks very well to events that Amazon can generate. Okay, the fact that your ECS task, your Docker, just stopped computing, it's done. Okay, the fact that you received a specific kind of log in your log stream, whatever kind of events, that's very, very practical. But the deployment model is quite different. I'm not going to go very much into it, but we are not. I don't think we are big enough, mature enough to really go there. The code sharing because you want some code sharing between all your Lambdas. When you have an application server, they all use the same code base, so they can benefit from all the code you write. Every single API that you write benefit from the entire code base. In Lambda, you cannot put the entire code base there. or so you have to do libraries, and it's a bit different model. The deployment tools are not the same, maybe a bit less mature also. So we use it for some specific thing when we want to look to hook into AWS events, but our business logic for the moment we are not ready to have it there, and I don't know if it could be a good idea. Okay, last story about compute. This is what in French we call une usine à gaz. We decided at some point to do some kind of manual auto-scaling. Okay, and so manually creating or removing VMs on the fly without using Amazon tooling. And there were a few reasons for that, and the biggest reason is our job, photogrammetry, is taking a few hundred images and producing a mesh. This takes hours. Okay, so in the Kubernetes world, often you say that when your task is encounters a problem because of a machine that fails or something, it can just get killed and restarted without any problem, because those are very small tasks, or because it's an application server, it's highly available, you kill one node, you don't care, you just bring it back a bit later. For us, because of how the underlying application was built, that was not really acceptable to say, oh, it's dead, you know what, let's just restart. That's hours of computation. So that's money for us, and that's latency for our users. And so we figured that, it was better, we were better off doing it on our own. We have large compute instances, we have 32 vCPUs per instances. So each instance runs a single project on 32 vCPUs. Those are not the biggest ones, but they are quite big already. The conclusion being, that was a bad idea. That was a bad understanding of what Amazon could provide. We might not be able to use all the defaults, but using Amazon tools would have been much better, now that I understand them better. Because this code that, as a proof of concept, was very easy to run, to create the machine when there is a queue and remove the machine when we have no project in the queue, became very, very, very complicated, as you can expect, actually. And we should have used Amazon tooling. So the point is, if something exists in Amazon and you are in this ecosystem, don't reinvent it. It's quite unreasonable in all cases. Okay? Bit of security. Very quickly on those topics, secret management. Just some information that I want to share with you. If you are in an Amazon ecosystem, inside the Amazon ecosystem, you don't need to do secrets management, because your VM will or your ECS task, Docker task, or your Amazon Lambda will have a role, as far as Amazon is concerned, implicitly accessible, and therefore will have access to your Amazon resources. So to access Amazon from Amazon, you don't need to manage secrets. Okay, and that's quite powerful. That's something that was not understood before I arrived in the company, and there were some secrets in GitHub. So there was no need for secrets really, because they are implicitly provided. If you want to do secrets management, because you need some secrets, because some of your things are not Amazon, like a GitHub connector, like whatever. You have SSM, for example, that has a parameter store that a lot of people use for putting secrets. It's just a key value store. It's quite practical. There are a few limitations. It was not originally meant for that, I think, but and therefore there are a few limitations. But for us, it works well, and it's free. There is Secrets Manager that is much more complex. That is to secrets management, and it will help you rotate the secrets by having procedures to change the password of things and keeping the new password in sync and all sorts of complicated things. We are not there yet. We don't feel that we need it. And key management service to manage your certificates or encryption keys. Yes.
Why not use Vault since you're using Terraform?
Because we need to deploy Vault. So we have actually a team that is using Vault, and so I went to them and I said, okay, now I'm interested, because that's comparable to that, I guess, but I would say Vault maybe in advance, because they have been doing that a longer time and they are focused on that. Maybe I have not compared those two. But I went to them and I said, okay, I'm interested. Can I use it? And they said, yeah, we have a single node and no recovery procedure. Okay, so I can use it for my prod. I use it for the CI systems. Okay, and to install Vault in high availability with shared keys and all of this, that's not easy. So that's it's always the same thing. If you want to do it yourself, even with this kind of tool, it's a lot more work. But I'm pretty sure it's a good product. Security as code, something I quickly touched on, but because as far as Amazon is concerned, firewalls and network rules are infrastructure. It's all in your Terraform definition. So my firewall rules are in my Terraform definitions. And better than that, because it's in the Amazon world, a firewall is called a security group. So in the security group, you have rules that typical firewall, right? From this IP with this port, you can access, or you cannot, or you can go in, or you can go out. But they have something a bit better, because those IP rules are always a bit complicated. They have a layer of abstraction. You can say, if you come from this security group, like my application server are inside the application server security group, if you come from this security group, you can go in. Okay, so for example, my database allows my application servers, and I don't need to know the IPs of my application servers. That change constantly. Okay, maybe a bit related to your DNS question earlier. So that's a power of this software-defined network and security groups, and it's in Terraform. And user access in terms of security. So there is a support for multi-factor authentication. You can force your user to have multi-factor authentication by basically disallowing them any action if they are not logged in with MFA. And the only action that you allow is for them to create an MFA. And that's what I do. So when I provision a new user account for a new employee, I give him a user password that cannot do anything until he has set up an MFA. So that's something you can do. And you have this tool that I like a lot, so I'm mentioning it, AWS Vault. When you do command line access to run Terraform, for example, or to access the AWS API from your local computer, you need to have a user password, access key and secret access key. That is your API credentials. And the problem is that by default, the Amazon tooling, the Amazon CLI puts it in a flat file in your home environment, so it's basically anyone that has access to the computer can see them. This tool will put them in the keyring of your computer, and will never expose them when you ask for credentials. So you launch your application through that, and when you launch your command, it gives a temporary set of credentials that is derived from your main credentials. So it does not expose them, which is a bit of added security. Always nice. Questions? Cool. Bit of organization, very quickly. We use several Amazon accounts, and this is to promote innovation. Every product team has their own Amazon account, basically. And so we do have corporate services, company services that are helpful for teams. But if a team is not happy with what the platform of the corporate services are providing, they can deploy their own infrastructure. They can do what they want, providing that they know how to do it. And it's the cost of either going into the square of what the company has or doing more on the edge innovation. So we do have an Amazon account per team. It's nice because the billing is separated, but it's also consolidated. So you pay a single bill, but you have the breakdown between the different accounts. And one of the best practices we use is a centralized user management, because when you have several accounts, obviously your users can have access to several accounts. Being an admin, I have access to them all, and I don't have a user account on each of those AWS accounts, because the day I will leave the company, some people will be very pissed that they have to deprovision everything. They will miss something, and I will do some Bitcoin mining on one of those accounts. So there is a single account that holds all the users, and you log onto this single account, and then you can jump on the other account with the switch role, the assume role mechanism, which is quite standard. And that means also that okay. There are a lot of things that I did not talk about that we are using. I talked a lot already, too much. Databases, messaging, networking, and so much more. I'm here for questions. The point is that we got tremendous leverage working with Amazon. Everything that I mentioned is less than 3 years. It's the original team. We were 3 backend developers that were doing infra at the same time. So at the same time, we were building this entire SaaS application. We were doing the infrastructure for ourselves. the people that are actually doing infra today are basically the same. So the fact that the backend developer has not really grown the people that do ops, a bit of ops. We basically don't have to do anything on a day-to-day basis if we don't want to change something, which is amazing. And every time we chose to build something that was similar to a service that is provided, obviously, I want to say, we regretted it because they have a bigger scale. It's quite obvious that they are going to do it better, less expensive, and so, yeah. And that's it. Automate. That's the most important thing. And I'm done.